Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on September 23, 2025, just yesterday. The big idea is a new way to compute learning signals in group relative policy optimization that adapts per query, fixing advantage reversion and the advantage mirror issues and lifting accuracy. For example, GO3K rises to 54.41% versus 51.91 and 52.91. The paper is titled MAPO, Mixed Advantage Policy Optimization, and the implications for model training are quite significant. In short, it mixes two normalizations using trajectory certainty, introduces an advantage percent deviation for high certainty cases, and shows stable gains across math and emotion reasoning benchmarks. Also, the authors share the MAPO code on GitHub. You will find a Python-heavy implementation with a code folder, an assets/asserts directory, and a README that includes the abstract, author list, and citation. There are no releases yet, a modest star count, and tags around foundation models and GRPO. On Hugging Face, find 3Q and 2.5 VL7 BRL fine-tunes around 8 billion parameters safe tensors, BF16 plus model cards, with transformers loading and inference examples to try locally. Well, Figure 1 shows that queries differ widely in how many successful rollouts they produce, which directly reflects trajectory certainty. Trajectory certainty means how consistently a query yields success across repeated samples, like a coin that almost always lands the same way. The left histogram clusters at extreme counts. The most diverse behavior centers at n equals 4 when g equals 8. The middle plot shows the advantage mean rising with successes, while the right plot shows the advantage spread peaking at mid-counts, so fixed normalization can misrank samples. So, Figure 1 showed why fixed normalization can misrank samples. Table 1 summarizes trade-offs across GRPO variants, which signals where cost and brittleness creep in. The think trajectory diversity family leans on input augmentation and increases thinking cost, often adding several knobs to tune. The reward formulation group introduces task-specific rewards and more coefficients. The advantage estimation redesigns add rescale factors or validity thresholds, motivating a simpler, parameter-free alternative. Alright, Figure 2 shows how the method mixes two advantage signals based on trajectory certainty, so the learning signal fits each query. The left panels depict multiple rollouts and rewards, with the success ratio summarizing how consistent the answers are. The center callouts introduce advantage percent deviation, which uses deviation over the mean for high certainty groups, while a z-score style advantage handles uncertain cases. The right curve plots the certainty weight lambda, which peaks at confident extremes and dips in the middle, and this weight blends the two advantages. Alright, Figure 3 contrasts existing advantage formulas and highlights where they break, while the mixed approach resolves both issues. Advantage reversion means tiny variation makes some rewards look wildly extreme, so training overreacts. Advantage mirror means two reward sets that are opposites get identical normalized scores, which hides real differences. The table lists prior methods, and the mixture adds a certainty weight that blends z-score style and mean relative signals for each query. So Table 2 reports an ablation that tests the two pieces of the method across math and emotion benchmarks. Advantage percent deviation means using deviation over the mean for high certainty groups, while trajectory certainty reweight shifts weight based on success ratio. With both enabled, GO3K reaches 54.41%. On the emotion side, emo set peaks at 77.86%. The math average reaches 51.26%. The emotion average reaches 66.77%, which shows the combo consistently wins. So Table 3 reports head-to-head results across math and emotion benchmarks. With G equals 12, GO3K reaches 54.41%, topping both GRPO and DAPO. The math average rises to 51.26%, which indicates better generalization across the 3 out-of-domain sets. On emo set, accuracy peaks at 77.86%. The out-of-domain average reaches 55.68%, which supports the claim of steadier training. With G equals 8, GO3K still attains 54.24%, showing gains even with fewer rollouts. Okay, 2 takeaways stand out. Mixing z-score style and mean relative advantages by trajectory certainty fixes reversion and mirror issues, and it delivers steadier gains across math and emotion without extra modules or knobs. The broader implication is simpler, more reliable reinforcement post-training for reasoning models. That is it for the AI Research Roundup. I am Alex. Thanks for listening.